Okay, welcome back to My Geeky Hobby. On today's episode, we are looking at a alternative version of the PCB for a very popular open source project of the PLA chip, replacement PLA chip for the C64, for the Commodore C64. So the PLA chip, which is like the programmable logic chip that controls a lot of the functions of the C64, is a commonly broken part in those old Commodore systems. And you often have to source a replacement, which the original is impossible to get. So for the last couple of years, there has been a pretty popular replacement chip or replacement PCB that can emulate that chip. It's called the PLA 20V8. And the author of this project has, shared the whole project and the details and the design, and there's a PCB and all the files. Really great work and an amazing project. But for myself, I've used those, but every time I use them, I really didn't like the design. I know it's really hard to squeeze the two chips in any other way, so that was sort of the best that could be done. But I was always thinking, is there a better way that we can get those chips aligned and just make it look a little bit better. So hence my idea of creating a little bit more compact version of this PCB. So let's head to the PC. This is my version of the PCB. I'll share all the files and all the design details. I'll make them available on my GitHub. There'll be a link in the description to a PCBWay shared project, and you can get your hands on one of those. I mean, what's the complication here, or what have I done? I mean, what I did is simply put one of the chips at the bottom of the PCB and the other chip at the top. Of course, this creates a little bit of a complication here because when you come to building this this version of the PCB, you will be always in the situation where a set of those pins will be hidden under the chip for one of those chips. No matter where you or how you start or how you try to solder it, it's always going to be a bit of a trouble to solder it. But I think I have a way to actually do it, and I've created so far a few of those SlimPLAs, and they all work, and they were not really that complicated to assemble. But ultimately, the PCB itself is pretty complex. There's quite a few connections that have to happen to get both of those chips cross-connected. So that's where we are right now. So what I'll do next is I'll show you how to build one of those. Maybe let me just show you first how it looks like in my C64. So this is my C64 with the final product inserted. So as you can see, it's pretty nice and compact, and it will be a great replacement for a PC for the PLA in your unit. So let me bring one of those to you and show you how it looks like. So this is the final result of this project. So we get this nice compact version of the PLA that can be inserted into the computer. For comparison, this is the original PLA chip. So as you can see, they are similar size. Of course, this one is a little bit fatter, so it might not fit, exactly the same way. But I mean, it's relatively comparable to the original design. But the good thing is, like I said, it's very compact. So that's the project. Let's try to build one of those, and I'll show you how to do it step by step. So first of all, we need to start with the PCBs, and for my project, PCBWay was the sponsor. They provided the prototype PCBs, so thanks to the team at PCBWay. So with the PCBs, the only other thing that we'll need is the actual chips. So we'll start by getting our chips programmed. We'll get our GAL chips programmed. Okay, so we'll start with getting the chips up and running. I would say the most important thing, and I mean, I can't stress enough how important this is labeling those chips. So we know that one of them is the right-hand side as per the original project, and the other one is the left-hand side one. You can use labels, you can print labels. I just use a pencil, and I'm gonna write R on one of them and L on the other one. Don't miss it, because you're gonna get confused which one is which. This is super important to do. Make sure you label them. And now we can proceed to programming the chips. And for the actual programming, I'll be using my MiniPro, the popular super chip programmer. That's the one I have. So let me take you to the other screen. Okay, so the files, where we're going to get the files from the website, from the project website, you know, from Free Pascal website. We're going to download the JED files. We need 2 of them. We need one for the right-hand side chip. It's very simple because there's one to choose from. And for the left-hand side chips, there is 3 different ones to choose from. Now, I never fully trust the chips that come from China, and I source my GAL chips from China. And because I don't trust the markings, I assume they might be remarked. They might not be the 25 nanoseconds chips. They might be the faster ones, because the stock of the slower ones is probably slowly depleting. So I wouldn't be surprised if those chips get remarked. So I'll assume that I'm dealing with the faster chips, in which case I will make sure that I download this alternative 2 or alt2 file for the left chip. So that's the 2 files that I will need for programming. If we get our software app, what we'll do is select first of all the correct type of chip. This is a GAL 20V8B. There's only one to choose from. And now let's start with the right chip. So we'll stick it into the programmer. We'll open the file in this software. So that's the right chip. We have the right chip in the programmer. We have the right chip file. Scroll and take a look. Make sure that there is some data in here in the software. Why? I'll show you in a moment why it's important. So we selected the right hand side chip. We selected the right hand side file. We're just going to do device, program, and let it program. Okay. So that's done. Now, if you think that it's as simple as putting the other chip in, so this is my left-hand side chip in the programmer. If I just select the other file, so that's the left alternative 2 file, look what happened. I don't know if it's a problem with the version of the MiniPro software that I have, but if you notice, actually nothing opened, or the buffer is empty, even though I selected the file. And you know, with this design, we only have one chance to you know, make sure that our file is correct, because it's going to be really hard to unsolder those chips if they are incorrectly programmed. So again, this time I'm going to select the file, and as you can see, this file, after selecting the buffer, has got all the zeros and ones. That means that the file was correctly opened. I think it's some kind of bug in MiniPro. I'm using the version 685, and looks like when you choose the buffer multiple times for the GAL chip, it just doesn't update the buffer correctly. So I reopened the software, and I'm ready to program the left-hand side chip. So device, program, and program. Okay, so that's programming of the chip, of the two chips done. So this will give us the two working chips that we need for our SlimPLA. Okay, let's continue. Okay, so to build our SlimPLA, of course we'll need the program chips. We'll need the headers for the pins, and preferably use those. So this is the, you know, machined, very precise, and most importantly, they are thin, so they will not ruin the dip sockets when you put the PLA into the socket. Because of the height required for the chip that is sitting at the bottom of the PCB, you preferably want these pins with the small area here that lifts the whole thing a little bit higher. So watch out for those. I'll try to put a link in the description for the AliExpress seller that I bought those from. Of course, we need the PCB itself. So I'll again put a link to the PCB where you get it from. Watch out, you know, obviously the PCB, it's very easy to confuse which side is which. There's a silk screen here that says bottom. So that's the bottom of the PCB. Also, watch out, because it's quite crowded with all those pins, with all these holes here for the, you know, for the pins of the chip. So the area for the bottom GAL, the right hand side GAL at the bottom of the PCB is clearly marked. So, you know, make sure that you put the chip into the you know, into the correct holes. Otherwise, yeah, otherwise it's going to be a trouble. And also don't get confused which side is which. Anyway, I printed on the silk screen here what's where. So the right GAL will go at the bottom of the PCB. That's important, yeah. We can't swap them around, otherwise it's just not going to work. So we'll start with getting the pins ready, and then we can progress with soldering. So for the pins, we need two sets of 12 to make it a 24 pin chip. Sorry, not 12. Two sets of 14. It's a DIP 28 device. So that's one, and that's the other. So that's pretty much all that's needed. We have those two sets of pins. We got the chips. We're ready to go with the assembly. Okay, so before we start soldering, let's do a little bit of prep work. So what I will do is just temporarily, I'll put the left chip, you know, the top one, into the top of the PCB and pretty much secure it there. I'm going to put a small spacer. This is literally credit card thickness spacer, to keep the pins a little bit higher than they normally are. Then I'll flip the chip and I'll trim those legs that are normally under the bottom GAL, because this will be in our way later on. Okay, so that's enough. You might as well trim the other side, it doesn't really matter. I'll trim the other side as well. Okay, so this will give us the chip with slightly shortened pins. So that's the left chip done. I'll remove it because we'll be soldering it a bit later. So same chip, but with the legs a little bit shortened. I'll do the same thing with the bottom gull, just to keep the legs a little bit, the leads just a little bit shorter. So flip and cut them. Okay. So this gives us the two chips and the much smaller or shorter leads. Looks like I missed one. Okay. Okay, next step. Let's get the bottom gull soldered. The bottom gull is the right hand side gull. Make sure you obviously put it into the right space. So like this. Okay. Let's not forget where pin 1 needs to be. So we got the cutout and the pin 1 on the chip itself, and we can start soldering. I'm gonna bring my amazing soldering help, which is this this vise. Okay, so at this stage we should be able to solder the pins at the bottom of the chip. Okay, so that's the bottom of the chip and the pins soldered. Now we can solder the top, or at least partially, because remember, one row of this chip is gonna sit in a way that is gonna be hard to solder at this point. But anyway, I just inserted the left hand side gull to the top of the PCB. Okay, I'll flip it and we'll get it ready for soldering. So that's done. We have the top and the bottom gull soldered. I'm gonna move this vise away, and I'll bring a breadboard, our pins into the breadboard. Just like that. Remember, we want oh, one of my pins is a little bit bent. Let me fix it. Okay, like this. So this is nice and steady. Let's solder that in. Okay, so that's done. Now is the last piece, which is the most tricky part of this soldering. Let me get my vise prepared. I just want to bring this whole thing a bit closer to you to show you the actual last bit of soldering clearly. Now I normally take it out of the breadboard on one side. Okay, remember, right now this row here is not soldered yet. So none of those pins here are soldered, but they are obstructed by the chip at the bottom. So we need to somehow solder it. And I only put into the breadboard the right hand side to give me the chip on a bit of an angle, to give me the whole thing on a bit of an angle. And it's probably a good idea to put a bit of flux . It will help the solder flow. Okay, and what we'll do is just solder the last piece, but we'll solder it from the top. If you see the solder disappearing, you know it's flowing into the hole and nicely filling in this solder joint. That should be it. I'll clean up this PLA and show you how it looks like after cleanup. So after I cleaned it up, have a look. Those connections are nicely securely soldered, and that new PLA is ready to be used inside a Commodore 64. So ultimately, you know, this gives us this really nice design of the PLA. I call it SlimPLA. It's this compacted version of the PLA. I hope you like the project. I'll share the design files, and the PCBs will be shared on PCBWay. You can order them from there. Anyways, thanks for joining me tonight, and thanks for watching my videos. I invite you to join me on the next one. And if you haven't subscribed yet, I'm slowly getting towards the first 1,000 subscribers, so help me to get there. Subscribe. I'll see you on the next one. Thanks for watching.